Good morning, Year 6. Today we're going to be thinking about, in our recap video, how we can estimate capacity. So to be successful in today's learning, we're going to understand what is meant by capacity as opposed to volume. We're going to understand what estimating means. We're going to consider how we can use facts we already know to support and influence our answers. And we're going to construct some estimates. Okay. To be thinking about capacity then. Capacity compared to volume. CF is a symbol which means to compare with in shorthand, so it's an abbreviation. It's an abbreviation of confer or conferator, which is to compare with in Latin. Again, Latin coming up like it did in our binomial system from science. Okay, so Latin is always prevalent within our language points. So capacity then, so volume is the total space covered by an object. Okay, so the amount of space taken up by an object. Capacity is how much stuff can be held within an object. Okay, so whether it be solid, liquid, or gas, how much stuff it can have in it. Okay, normally they're very similar values, but the use is slightly different. Okay, so capacity is how much can be held within a shape or an object. If we're looking at estimating, then estimating means to make a judgment based on what we know. And if we look at the number, we were asked to estimate how many marbles there are, so what the capacity of this jar is to hold marbles. So if we look at it, we can see there's 5 along the base, and we can see there's 1, 2, 3, 4, 5, 6, 7. So there's 7 or 8. There's 7 or 8 on the left-hand side. So I'm thinking roughly 5 times 8. So if I think about that, I was nowhere near. And the reason for that is what I'd done was I counted the rows, but I hadn't looked how they were going over the top of each other. So sometimes we need to go more than the known facts we've got. So if we look at the bottom, we can see there's 5 along the bottom. Then we can see on the side there's 1, 2, 3, 4, 5, 6, 7. Now that would be 5 times 7 is 35. But if I see that there's one marble in front of another one, in front of another one, I know that it's going to be significantly more than that. And if I know that each marble has at least one marble behind it, I can double my 35 and suddenly I'm at 70. A sensible estimate could have been up to 80. 5,000 would have been a ridiculous estimate. So we've got to make a value judgment of what constitutes sensible. Here I can see that this jug has 550 millilitres of water within it. Now the whole jug, the container, what do we estimate? Well, let's see how we work that out. I've got a bar model, my friendly bar model here, 2 yellow bars. Each one shows half of that. Now I can see that my blue level is slightly above half. So that means there's less than another 550 to go. So 550 plus less than 550. So I'm imagining, about 1,000 milliliters, about a liter. Okay, my estimate of a liter is just above half full. Okay, so if it's half full and a little bit more, and it's 550, then it's less than 550 to go. So 1,000 milliliters, 1 liter would be right. Okay. A is 250 milliliters. What do you estimate B to be? It's obviously more, and C is significantly more. So what's your estimate for C? Okay, have a think, have a ponder. I can see, because these are going to be 3D bottles, so it's not just going to be a bit wider. I'm thinking more than double for B, and I'm thinking significantly more for C. But here we've got tripling the value of A for B, because it's getting taller and wider and deeper. And for C, it's a lot wider. It's a lot taller and it's a lot deeper. Okay, so if we think about B being 3 times as big, what we've got is C being 12 times as big. These are approximate because we don't know exactly, but we're making estimates. We're using what we can know. I'm not thinking 3 million litres because that would be a silly estimate. We've got B here. How many cups of rice would it take to fill A? Okay, I look again at what I know. B is significantly smaller, maybe 3 or 4 times as small as A. And then I'm thinking again higher, wider, deeper for B. So I'm thinking if it's 4 times for A, I'm thinking maybe 8 or 10, maybe 12 times for B. So let's have a look. I'm saying, oh, it's a lot more than I thought. So again, guys, you've got to see what you can see from your own experiences. Because I thought that the yellow bowls were not as deep as they actually are. So they're lots deeper, and they're wider. So therefore, you've got to think through. 10 cups for A and up to 30 for B. This is quite challenging because you've got to visualize these as 3D shapes rather than 2D shapes. Haley says here that she knows that there's 24 chocolates in this jar. He estimates that this jar has a capacity of 70 chocolates. So what do you think to Haley's perception? I disagree with it, and as does the question here. And the reason I disagree with it is when I've looked here at my bar on the side, The whole jar would be the red height, and I know that there's 24 there at the moment. 24 is taking me up to approximately one of my four sections, so one quarter. 24 times 4 doesn't make 70. It's nowhere near. So I'm thinking it's a quarter full, so therefore 4 times 24 would be 96. And as it's an estimate, it's slightly less accurate. I might have said 100 as an estimate, so it's an approximation, but 96 or 100, yeah. But if you go, you see, you almost bar it up in your head. It's challenging with 3D shapes, and therefore you've got to take account of them being that third value of width, height, and depth. Okay, so you need to think of all three things when you're perceiving them. Okay, yeah. Here then, a couple of activities for you. So pause the screen, pause the video now, please, and look at what the capacity would be for 4B and for 5B A. Sorry, for B and C for the second ones. Pause the video there, please. Once you've done those, have a look at this second one. I'll move my face off the bucket. So how many cups of rice? Remember, the rice are quite challenging ones, and look at the shape for the bottle for A and the shape for the bucket for B. We had 10 and 30 earlier. What do you think? Is A going to be smaller than 10 or more? What do you think? Okay, guys, pausing the video there, and then having a look at your answers for these now, guys. I'd say, yeah, about 3 times as much for 4B, so approximately 450 milliliters. And again, for B, for the bottle for B, it's 3 times 450, so it's 1,350, and then 10 times for C. For 9A, then, we've got the idea about 4 cups for the blue bottle, and then thinking of the blue bottle being about 6 times smaller than the yellow bucket, and therefore it's 24 red cups to fill the yellow bucket. Okay, guys. Thinking now, um, one of the containers has a capacity of 450 milliliters. So what's the capacity of the containers to complete the statement? What do you think they are if one's 450? See if you can work it through. And then have a look at what Sid said. Sid said over here, so pausing it if you're still on first one. Sid says, I put 62 mints in the jar. He estimates it's going to be 150. Do you agree with his estimate? Do you think that's a good estimate or a poor quality estimate? What do you think to Sid? Pause the video while you work through those two, please. And then looking. So we say that A is 300 mil. B is 450 and C 600. If you picked A or C as the one that's 450, then as long as there's the gap between each of approximately so that the smallest is half the size of the biggest, then that would be approximately right. So if you said C was 450, then A would need to be 225. If you said A was 450, then C would need to be 900. Sid then 62 mints in the jar, 150 capacity. What do we think? No, it's far too low. I'd say, yeah, at least it's not even, I'd say it's barely a quarter full. So therefore, you'd multiply 62 by 4, so 248 would be an approximate estimate that would work. Guys, today on your worksheet, you're going to be looking at some algebra again, two-step rules. With this, doing function machines, it's like being in year 2 again. Algebra is just maths. It's just maths. It's just got a fancy title. Okay, so when you're going through this today, do look at the rules for the function machine. Do try, where it says explain to a partner, try and verbalize to somebody at home what's going on and try and write a sentence there. And again, function machines here, just work through what you're being asked to do. Try and work through every number sentence. And if you're not doing them on the sheet, if you can still write the operation between them, so you do the arrow and then do the add or the subtract or whatever needs to happen within them, if you could show those within the whole line of the rather, don't just basically fill the boxes in if you're not doing it on the sheet. You've got to tell me what each step. I don't understand your notes otherwise, guys. Okay, guys, you're getting some answer sheets today. The percentages ones will be coming, so they're from earlier in the week and should address any questions you've got about those. The algebra will come next Tuesday, I think. So next Tuesday they'll be coming to you, the first few algebra ones. Thanks very much for your attention today to the recap video, and I hope you enjoyed the algebra. See you soon, guys.